Hi, in this clip I will discuss food perception as it is the basis for sensory science. Food perception may sound easy, but is actually not such a simple concept. I will explain food perception by introducing two concepts, psychophysics and psychohedonics. Psychophysics is the relation between the physical chemical properties of a food and the perception of it by the consumer or panelist. For example, how sweet you perceive the taste of this banana when you take a bite is related to its sugar concentration. Where psychophysics is an analytical field of research, psychohedonics focuses on the relation between physical chemical properties, so concentration, and the pleasantness or liking of a food, the hedonic or affective value of it. It is important to be able to distinguish between those two concepts, and I will tell you why. Psychophysical functions represent the correlation between perceived intensity and concentration. You can imagine that your perception of sweetness intensity increases when the concentration of sugar in a product increases. In this case, the function is positive and linear on a logarithmic scale. The logarithmic function means in practice that the increase in perceived sweetness intensity between 5 and 6 grams of sugar in the solution is equal to the increase in perceived sweetness intensity between 50 and 60 grams. You can plot such a psychophysical curve for smell as well, but these are usually not so straightforward. So let's look at some psychophysical functions from real data. These two graphs represent data from normal weight and obese subjects. You can see that overall, the psychophysical functions are more or less the same. They're in the same direction with similar slopes. And of course, there is some variation between subjects, but there are no big differences. This graph depicts a psychohedonic function, also called a Wundt curve. It shows the relation between concentration and liking. And at the top, you can find the optimal liking point, also called bliss point, which represents the concentration that is most liked. For sugar-sweetened beverages, we know that this optimal liking point is found at a 10% sucrose concentration. In the food industry, product developers are constantly looking for this optimal liking point for their products. And indeed, most commercially available sugar-sweetened beverages contain around 10% of sugar. However, there's a lot of variation between people, and often different segments or groups of people have different bliss points. So again, let's look at an example. In the figure here, you can see two sets of data again, from normal weight and obese persons. You can see that both graphs are quite messy and show a lot of variation in the individual psychohedonic functions. So it is important to remember that we may perceive taste intensity similar with increase in concentration, but our hedonic response to it is very personal and can differ from person to person. Based on years of research, we now know that demographic factors such as age and gender, or how hungry or satiated you are, can influence sensory perception. These factors can have an effect on threshold sensitivity, on suprathreshold sensitivity, and identification ability. But also liking and preferences can differ because of these factors. However, it is also important to realize that these factors do not influence all our senses and perception in the same way. For example, there is a clear age-related decline in the ability to perceive and identify odors, but this happens to a lesser extent for taste. Besides individual differences, also external factors have major impact on how you perceive a food product and how you evaluate its pleasantness. An example can be the order in which you taste samples. Over time, fatigue may arise with the panelists, and they may rate later samples differently than in the beginning. So it's probably wise to randomize your samples when doing an experiment to prevent this order effect. Also, it might be good to repeat your samples for more reliable ratings. This figure shows relatively good replicability of the intensity ratings of the same tasted concentration when rated twice, so it probably represents a well-trained panel. But when different concentrations are tasted in a row, you also have to take into account any order effects. When first given a high concentration and then a low concentration of a tastant, you'll rate the intensity of the second concentration differently than when you would have tasted that one first. So keep in mind that perception is always relative and depending on previous experiences. So all in all, this is called your frame of reference, and this is important in determining your experimental setup. To sum up, in this clip, I discussed the concept of psychophysics and psychohedonics for food perception and the differences between them. You now know how to interpret these functions and how different factors can influence them.